Today we're going to talk about two things. We're going to talk about a thing called displacement and also total distance, or sometimes it's called total distance traveled. Okay, so what I want to talk about is a runner, okay, that's running, in this case running towards the right, okay, and we have a scaling down here, and where this is the negative side and this would be the positive side. So you can think of it as being like the x-axis, okay? And so we're moving left and right, okay? And then what this would be right here is called the initial position, or its starting position, and we call that x. And in physics, we use subscripts. So they're a little bit lower, so we use a little I. And the I stands for initial. And then this is where he ended up, and this arrow's telling me he's going this way, okay? And this is x sub f for final, okay? Then what it is, the displacement is the change in position. So if we go from xi to xf, that would be delta x. So this is called delta x, my change in x. It's kind of like slope, but only in one direction, okay? So displacement is the change in position. So delta x is x sub f minus x sub I. So this is what's really important. It's the final position minus the initial position, okay? And it's always has to be in that order, okay? Now, if we were, this is going side to side, but if we were going up and down, then we would say delta y is equal to y, the final position of y minus the initial y sub f minus y sub I, okay? But it's always, always, always the final position minus the initial position, okay? All right, so let's go and do some more work on this. So in this first problem, okay, this runner's starting at 2 and his final position is at 8. So x sub I is equal to 2 and x sub f is equal to 8. So my displacement, or my delta x, is equal to 8, because that's the final position, right? Minus 2, which would give me 6. And let's put units on this. So let's say this is centimeter, or let's say meters. So this would be 6 meters in the positive direction, because that's a positive 6. Okay, down here on this next problem, the initial position of the runner was at -5. The final position, x sub f, is at 2. So our displacement would be delta x, which is 2 minus -5. So 2 minus a -5 like this. And so that'd be 2 plus 5, which would give you 7. And again, let's call this meters. So this is meters. All right, let's do one more. I'm going to slide it up a little bit here. Okay, so on this one, the initial position is x sub I, which is at -9, and the final position, x sub f, is at -4, and the displacement, or delta x, is equal to -4 minus -9, and that becomes -4 plus 9, or 5 meters. Now, I want to talk about, all of these came out to be positive, right? And look at the direction that they went. So if we were going in the positive direction, which means in this case, if we're going left and right, that means we went to the right, okay? So the change in position is right this many. If we were going up and down, then that would mean that's how far we are from the initial position. We're 7 meters away in the positive direction. So up, or in the positive direction, if we're going left and right, in the positive direction x, or to the right, okay? Let's do some negative ones. So in this case, we start right here on the right-hand side, let's say at 8. So x sub I is equal to 8, and we end up here at 2. So x sub f would equal 2. So that means my displacement, delta x, would be 2 minus 8. And then 2 minus 8 is -6. And again, this is in meters, okay? So -6 meters. So that means we went to the left 6 meters. That's what the negative is gonna mean. Or if we were going up and down, we'd be down 6 meters, okay? And notice it's going left. See, all of these are gonna come out to be negative because our movement is to the left, okay? So for this one, my initial position, x of I, is equal to 0. My final position is at -6. Okay, so my displacement, delta x, would equal -6 minus 0, which would gives you -6 meters. Okay, let's do another one. Let me slide it up. Okay, so this one, the initial position is at -3, so x of I is equal to -3, and the final position, x of f, is equal to -9. So my displacement, or delta x, would be -9 minus -3, and that'd be -9 plus 3, or -6 meters. Okay, so I didn't mean for all these to come out to be -6, okay, but they all came out to be negative, right? And they all just happened to be 6, okay? So what does the negative mean? It means you moved left, okay? So the difference between your initial position and your final position is you've moved to the left 6 units. If you're going up or down, then that would mean from the initial position, you've moved down 6 meters, okay? I should say this. Positive, let's write this down. Positive displacement would mean you've moved up or you've moved to the right. And negative displacement means you moved either left or down. Okay? So this is going to be similar to the problems we look at, okay? So one thing we got to recall is this, north, south, east, west, okay? So this is north at the top, this is south. So if we're starting on the south side, that's going to be the negative side. And if we're starting on the north side, that's going to be positive. If we start over here on the west side, that's going to be negative. And if we're over here on the east side, okay, north, south, east, west, okay, on the east side, then that's going to be positive. So this is like positive x, positive y, negative x, and negative y, okay? So I'm going to ask you 2 questions here. I'm going to ask you how far they traveled, okay, and also what the displacement is. And they're not the same. I want to make that really clear. The distance traveled and the displacement are not the same, okay? So a runner begins 20 meters east of the park. Okay, so that's the initial position, and because we're east, right? We're east. That's going to be positive 20. So we know x sub I is equal to 20. Okay, so we know we're going to be moving in east and west. So a runner begins 20 meters east of the park gate and runs 45 meters east. So that's going to be a positive 45 because of east. And then the runner turns and runs 35 meters west. And that's going to be a negative 35. Let me just come up here. That's going to be negative 35. And then runs for the final, because that'd be going left like we did earlier, okay? And then turns for a final time and runs 5 meters east, okay? So east is going to be positive. So that's a positive 5. And then stops running. So that's, after we make this movement, we're going to be at our final position, and that's going to be x sub f. So x sub f is going to equal, okay, so we started at 20 and 20 meters. So that's the start. And again, positive 20 because we're on the east side. If I said the west side, it would be a negative 20. And runs 45 meters east. So I'm going to take the 20, I'm going to add 45. The runner then turns and runs 35 meters west. So now that's going to be plus a negative 35. You could also write this as minus 35. And then the runner turns for the final time and runs 5 meters east. So we're going to go in the positive direction again. So positive 5. So we're going to add 5. So that means the final position we could get by taking the 20 and adding 45 and then taking away 35 and then adding 5. So 20 plus 45 is 65 minus 35 is 30 and then plus 5 is 35. So if this is like the x-axis, we started on 20 on the x-axis and we ended up at 35 on the x-axis. So what's my displacement? So my displacement, the net change, sometimes that's what this is called too, would be x of f, which is, or my delta x, which is 35 minus 20, which gives you 15 meters. Okay, so we're 15 meters to the east of the gate. Okay, now what's the total distance traveled? And this is going to be a little bit different. Okay, is the total distance or the distance traveled. Okay, so we started at 20. That's not a distance that we traveled. That's just the location that we started at. So we traveled 45. So this would be 45. And then turns and runs 35 meters west. So when we talk about distance traveled, we don't worry about the positive or negative because we went 45, we also went 35, and we also went 5. So we're just going to add these without the positive and negatives. So it's going to be 45 plus the 35 plus the 5. So 45 and 35 makes 80 plus 5 makes 85. So I want you to understand these are different. The displacement and the distance traveled or the total distance is different, right? Displacement and total distance are two different things. This is actually how far you moved versus what's the difference between the start and the finishing positions, okay? The difference between the start and the stop is 15 meters to the right, okay? All right, guys, that's it. I said this, but I didn't write it, okay? Total distance, and I should have written it. Total distance does not, sometimes it does, so I don't want to say it never, okay? So total distance is not the same as displacement. So I'm going to ask you a question real quick here, okay? Let's say you were born in a hospital. Let's say you were born at the Selma Hospital right there on Rose Avenue. And you grew up here in Selma, you moved around, and then you died at the Selma Hospital. So what was your displacement for your lifetime? And the answer would be 0. What? Why? Here's why. Where did you start at? You started at the same position you ended at, right? That would mean that when you take the x of f minus x of I, they would both be the same and you would get 0. So your displacement for your lifetime would be 0 if you were born and died in the same hospital. Okay, kind of morbid. Sorry, guys. All right. Okay, so keep that in mind, because I'm going to ask you some conceptual questions like, do you actually understand displacement? Okay. All right. Okay. Now I'm finished.